Okay, this question, they give us a function. They're asking us about local mins and maxes. How do we find those? Well, it's all about the derivative, right? Because when the derivative is zero, that's where you're going to find your maxes and your mins. Why? Because the derivative is the slope. And when the slope is zero, right? Imagine a little graph. A function goes up and then goes down. At a max, right? If you're a little roller coaster, you're flat. Your slope is flat at a max. And if you're at the bottom, your slope is flat again. At a max or a min, your slope is flat, your derivative is zero. So let's take the derivative. All right, this part's just zero. This is one power comes down, so this will be three. Oh, and the x is gone, huh? Because we subtract one, it's just gone. Now this is going to be minus 27 because that comes down, hits negative one. X subtract one to the minus two. Okay, okay. So then, now, we're going to set that equal to zero. We want to know what is going to make that derivative equal zero. How do you solve this equation? How do you solve for x? Well, let's jump the 3 to the other side. So we get minus 27, x to the minus 2 equals minus 3. And maybe it'd be best what is x to the minus 2? Do you realize, you remember, that means over x to the plus 2. You remember that? Negative powers want to jump down to the other side and then they become positive. So important that you know that going forward in math and science. Negative powers jump to the other side of the fraction, then they become positive. So we get to here, and now how are we going to solve? Well, I would suggest putting this over 1 and go diagonal, cross multiply. So we get minus 27 times 1. We get 2 times x, or what am I doing there? Minus 3 times x squared. Right, good? And then, so this is just minus 27. This is minus 3x squared. We're getting close. Divide by minus 3. Bring it over here for a second. We have got what? That's been positive 9 is x squared. Look at that. We're almost there. Now we root it. So x is 3. Careful. You got to put plus or minus when you put a root on. Really important. When you put a root on both sides of an equal sign, you got to remember to put plus or minus. It's so easy to make that mistake. I made a dumb little saying to help people remember it. When you put a roof on the house, you got to go up and down the ladder. Like if you're going to put a new roof on your house, you're going to have to go up the ladder, down the ladder. Plus and minus is like my up and down. Sorry, it's really dumb and dorky, but ever since I started saying it, people remembered better. So when you put a root on both sides of the equation, you got to put plus and minus. You got to go up and down the ladder with proof in the house. Don't forget that because we know really 3 or negative 3 squared is 9. You know it's right, huh? 3 squared is 9, but so is negative 3. Negative 3 times negative 3 is also 9. So we know they're both right answers. Okay, so positive 3 and negative 3. So, and we see that's the case, negative 3, positive 3. Now, though, how do you know which one's a local max, which one's a local min, all that kind of stuff? Well, you got to go to the number line. So I'm going to go to a number line now, and I'm going to put my values on there. So I'm going to go like, okay, like here's negative 3. And here's positive 3. Right? Negative comes before positive, as you knew. And then you just give yourself a section there. Whoop, didn't hold that long enough. Huh? And just make a little section out of it. Okay. And we got to find out if those are mins or maxes or what they are. So you got to check in between. So I'm going to pick some kind of point to check like negative 4. I'm going to check negative 4. I'm going to check in between, like how about 0? Check 0. You could do negative 2, negative 1, 1, 2, anything in the middle there. It doesn't matter. And then something to the right, 4. I'm going to check 4. Okay, here we go. Check what? Check the first derivative. Here's the first derivative, right? 3 minus 27x to the minus 2. And I'm going to take that negative 4 and I'm going to plug it in. And I'm going to find out what the first derivative is. So I'm going to go to Desmos, 3 minus 27. 3 minus 27, negative 4 to the negative 2. So 3 minus 27, negative 4. Let's try it again. Negative 4 to the power negative 2. I think I got that right. 3 minus 27, negative 4 to the negative 2. Is that right? 3 minus 27, negative 4 to negative 2. Yeah. So what was my answer then? It was 1.3125. 1.3125. So 1.3125. All I really care about is it's positive. Remember, derivative is a slope. Slope is positive. The function's going up. Okay. Let's check the middle. Let's check zero. Same thing. First derivative. Same. Just keep plugging into that same first derivative. This time I'm going to take my zero and put that in. Oh, zero is going to be a problem. Let me show you. If you put in zero, it's going to go air because you can't take zero. Let me show you. Undefined. You can't take zero to a negative power because that puts zero on the bottom. You know what I mean? If you have zero on the bottom, this means 20, this is 3 minus 27 over x squared. If you put zero in there, that's 3 minus squared. That's 3 minus 27 over 0. 0 squared 0. This is infinity, actually. You can't divide by 0. Right? Because how many times does zero go into 27? It goes in forever. It's infinity. So we can't do zero. So instead of checking zero, how about I check positive one? Anything between negative 3 and positive 3 is fine. Let me go back, change it to positive 1. Positive 1. What do I get? Negative 24. Negative 24. So let me erase what I did. Get negative 24. Yep, change my color. So which means the slope, remember first order slope, is negative. It's going down. The function is going down in that zone. Finally, I'm going to check the last one. The first derivative is 3 minus 27 x minus 2. Take the 4, plug in a 4 now. Make that a 4. Boom, boom. There it is. Same thing we got for 1.3125. Of course it is because it's squared. 3.125. It's positive, which means the slope is up, the graph's going up. Okay, so what have we discovered then? This graph then must be going up in this section, down in this section, up in this section. It's got to be, right? It's going up, down, up. So that makes this point right here a local max. This is a local max. And this is a min, isn't it? Local min. So this guy is a local min. All right, that's what they were asking us for. Which one, right? So negative 3 is the max. Is that right? Yep, negative 3 is the max. And positive 3 is the min. And then the other thing is they want the value. So that means they want you to plug into the original function. Let me plug into the original function. It's 5. So they want the value means from the original function, not the derivative, but the original function, up here. So I'm going to go to Desmos and plug in negative 3 and then 3. Negative 3 and then 3. A lot of Desmos usage here. So it's 5 plus, what was it, 3? And it was negative 3. Oops, oops, oops. Negative 3 plus 27. And then again, negative 3 to the negative 1. There it is. I got negative 13. Is that what they got for their first one? Yeah, negative 13. Now I'll plug in positive 3, hopefully get 23. Positive 3, hopefully get 23. So we come up back up here. Get rid of that negative and that negative. There it is, 23. Beautiful. All right, so I got those values, answered those questions. That's right. It's always satisfying to see the actual graph. Let's see. We're done, but let's see that we just found truth. Let's plug that into the actual Desmos grapher. So if I go to the actual Desmos grapher, here it is. There's some other function I had on there. Let's erase this one. Put in the new one. What is it? 5 plus 3x. 5 plus 3x plus 27x minus 1 plus 27x to the power minus 1. There we go. There's our graph. So notice, yeah, can I help us notice? Whoop. Hmm. out of the way. So yeah, you might think, whoa, that's different than we thought. Well, it might look a little different than we thought, but it's actually doing what we said. It's kind of hard to see it. Let me help. Yeah, yeah, there we go. Now we're seeing it better. It's yeah. Here, I'll just copy it right there. So here's the graph. This one turns out to be a little more tricky. I mean, it's still generally doing what we thought, but we that part in the middle we didn't know about. Let me help you. Let me help you see it here. Get rid of the Desmos heading there. Okay. So, all right. So what did we say? We said, well, we said we said the graph's going to go up, up, up till it hits -3, then down, down, down till it hits +3, and then up, up, down, up, -3, +3, right? Well, it technically does do that. It's hard to see it a little bit. Here's -3 right here. That is a max. It's a local max. It is going up just barely before that and then down after. And then this is all going down as well until we hit +3. That's a local min. And then it's going up afterwards. Now you might say, yeah, but what about this part in the middle? Yeah, that's where we would have to do a little more analysis. Um, but the up down thing is still true. It's going up here and then down. This is also down. Yeah, but you see, yeah, but where? We're way up. Well, that's because it had a vertical asymptote. See, we didn't test for vertical asymptotes, but it is true. It's decreasing in this section and decreasing in that section. And we did see that when you put in 0, there's something weird going on. Remember, we got that the derivative didn't exist there, right? Derivative is infinity there. So yeah, that's a critical point as well. Here's the local min. And so there we go.